Hello there. This video will show you how to do the first part of your fourth Excel assignment, which involves running a correlation analysis and creating a correlation table, and I'll show you how to do that in APA style. Also, how to generate a regression equation to make a prediction about a single dependent variable based on a single independent variable, and then also how to create a scatter diagram that has your regression line in it. There'll be a separate video to show you how to use pivot tables and the chi-square function to do a chi-square analysis. But for now, we're just going to focus on basic correlation and regression. So in this assignment, I'm having you look at a study that examined how somebody's income level and the perceived income level of their social circle has an impact on perceived wealth inequality in the United States. Also on how likely they are to be willing to redistribute wealth in terms of political policy, helping out the poorer, less fortunate people in the country. And then also they looked at their political leanings, liberal versus conservative. So I encourage you to read this study overview on your own and also look at the journal article that accompanies this assignment. It's really interesting stuff. So let's quickly take a look at the data just to see how you're going to end up answering all these fun questions. So if we look at the data here, we've got our subject ID, that's our first column. So as you typically see in Excel, each row represents an individual, and this is all their data. And then each column represents a variable that was measured among that individual. So we have their household income, then the average or the mean of their social circle's estimated income. So they were asked, on average, how much do those in your social circle make a year? They were also asked to estimate the population income, the mean population income at large, so for everybody in the United States. They also had some really unique ways to measure these two things, but I'm going with the most simple version of this data. So if you read the method section, you'll see they did all kinds of stuff with these two variables, but I'm keeping it simple here. Also, you'll see that they asked them about the fairness and how satisfied they were with the current distribution of wealth in the country. And those, if you look at the little comment here, there was 2 items. So these numbers down here represent the mean of those 2 items for each person. Each item was rated on a 1 to 6 scale with higher scores indicating more perceived fairness and more satisfaction with the current distribution of wealth. You also see this redistribute income variable here, and this was the mean across 4 items that were rated on a 1 to 6 scale, where higher scores indicate being more in favor of, social welfare and distribution of income and resources. Then here you'll see political preference. They were simply asked to rate what their political leanings were on a scale from 1 extremely liberal to 9 extremely conservative. And then I used these ratings to create a political category. So anybody that had a rating of 1 to 3, they were labeled liberal, 4 to 6 moderate, and 7 to 9 on this political preference variable, they were labeled conservative. You also have their sex, male or female, and then their age as well. So before you can jump in and start doing all the fun things with correlation and regression, make sure that you have your data analysis Toolpak installed. So you want to go up to File, then go down to Options, go to Add-ins over here on the left. Then you want to look for Analysis Toolpak, go down here where it says Go, click that. Make sure Analysis Toolpak has a check mark next to it, and then click OK. And then when you go to the Data tab, you'll see that there as an option. So let's go ahead and take a look at the assignment. So we just installed the Toolpak. Now we're going to run a correlation analysis for all numeric variables. And let's be specific with that here. All numeric variables. Because you can't really run the same type of correlation with non-numeric data. We're going to stick with Pearson's R, linear correlation among numeric variables. We're also going to create an APA-style correlation table, and I'll show you how to do that step by step. Okay, so let's go ahead and go under Data, the tab, click Data Analysis. And actually, real quick, I want to talk about a couple things with correlation because I noticed something here. So with correlation, it's kind of finicky in Excel. Notice that this says none missing. If you have anybody with missing data in your data set and you try to run a correlation analysis, it will not run for you. So I had to go through and clean this data to get rid of any participant that had any missing data for any of these values. So you'll notice when we compare our correlation table to the correlation table presented in the article, there are a couple of slight differences. And that's because they probably ran it in SPSS, where you don't have to have everybody having complete data to do that. So we have a few less participants in our data set than what they ran because we got rid of anybody with missing data. Another thing that's important to note, if your variables are not adjacent, it will not run the correlation analysis. So I want to include age in this analysis, but age is kind of separated from all the numeric variables by these two categorical variables. So in order to run the analysis with age in it, I'm going to just right click here and click Insert. And then I am going to grab age, just click the K, right click, cut, click the H, right click, paste. So now I've got age right next to all my other numeric variables. So again, for correlation and regression in Excel, you can't have any missing data, and if every variable that you want to look at needs to be adjacent. So now we can do this. All right, data analysis. Find correlation, and then click OK. Now we're going to select our input range here, and we're basically just going to highlight all of the labels and the values for all the numeric variables in our data set. So let's go ahead and do that. You can click and drag to do it, or you can click the top left cell for the data you want to highlight, and then scroll all the way down and go to the bottom right. Hold the Shift key, so I'm holding Shift on my keyboard, and I click it, and it just highlights everything from that point to this point, which is really handy. But if you just want to click and drag to highlight, you're welcome to do that as well. All right, grouped by columns. Yep, every variable has its own column. Labels are in the first row. And then I want to make a new worksheet, and I'm just going to go ahead and label this correlations. So, correlations. All right. So now let's just click OK. And you'll see this new worksheet popped up at the bottom here. I kind of like to have my data at the beginning, so I'm just going to click this and scoot it over. See where that little black arrow is? You don't have to do that. That's just a personal preference, but now you know how to move tabs around in your worksheet. Now this is a hot mess. We got to fix this before I even want to look at it. So I'm going to right click, make sure everything's still highlighted, go to Format Cells, and we're going to round these values to the hundredths place because that's typically how we report correlations. It's being slow though. Okay, here we go. Number, 2 decimal places, click OK. It's a little better, but it's still cutting off some of the words, right? So if we go to the Home tab and then go to Format, we want to auto-fit the column width so that the cells will hug the data that's around it. Now we can actually see all the things. So if we look at this, let's go ahead and turn this into a very beautiful APA style table. And we'll go ahead and do that within Microsoft Word. So let's go ahead and copy this, Control C to copy, or you can right click and hit copy. Well, let's go ahead and go into our assignment. Control V, oh, let's hit backspace to get rid of that number 2. Control V to paste. And look at this, this is crazy. So let's go ahead and do something really quick to see if this will be fixed. So what we want to do, we don't want to have the full labels across the top here. And for now, so it'll fit, let's just click on this little 4-cornered arrow up here, go up to Layout, AutoFit, AutoFit Window. So now it's shrunken so that we can see everything. So let's go ahead and clean this up a little bit. So we're going to put a 1 dot period, household income, and then 2, and you'll see why I'm going to do this here in a minute. Oh, not 36. What the heck? Got there. All right, 4, 5, 6, and 7 for age. Okay. And now what we can do, instead of having all these things labeled up here, just delete those. 1, 2, 3, 4, 5, 6. Whoa, it got a little crazy there. 6, and then 7 here. So now it's starting to look a little bit better. This is kind of ugly as well, so maybe just get rid of the little underscore. So just household income, social circle, mean income. Just get rid of those underscores. You can't really see them right now because of all the red that's happening. Okay, income distribution. So maybe fairness and satisfaction. Ooh, that's not how you spell satisfaction. Satisfaction with wealth distribution. We'll just abbreviate that. Redistribute income. Favorability of redistribution of income. Political preference is pretty straightforward. And then we've got age as well. Now there's a couple things that I want to point out before we start to really format this table and make it even more beautiful. If you notice along this diagonal here, you just see ones. And that's because, of course, household income is perfectly correlated with household income because it's the exact same variable. So you can keep those ones there, or you can just get rid of them. Typically, that's where you would put something called Cronbachs Alpha, which is a different type of statistic that you compute when you have a multi-item scale that you're using, kind of like the redistribution, favorability redistribution item. And Cronbachs Alpha just tells you how well all the items on that scale are correlated. But I'm not going to make you do that, so you can just leave it blank. Also, you can just get rid of this column 7. Just highlight it. Whoop. And then backspace to get rid of it. If you hit delete, it won't do anything. All right, we're almost there. We almost have a really beautiful, perfect AP style correlation table, but we're not quite there just yet. So I'm going to hit Control-I to unitalicize these. And now we want to label this table. So if we're in the top row, under the Layout and Table Tools, you can hit Insert above. And we want to merge those cells. So let's do that. And then we want it to be left aligned here. So you just click this right here under Layout. And we're going to say Table 1. And then in italics, 0 order correlation coefficients for all variables in the study. All right. Now at this point, we don't have any indication of whether or not any of these are statistically significant. Now our sample size in this study is, let's look. So it's 296. It goes down to 297, but that's because our first row are the variable labels. And the critical value for that is 0.11. So you'll see that reflected on your assignment right here. So what I want you to do next is just go through and bold all of the correlation coefficients that are statistically significant. So anything with a value of 0.11 or higher or negative 0.11 or lower is significant. So go ahead and pause the video and do that. All right. Now once you've got that accomplished, you can go back to the bottom row of your table under the Layout tool and click Insert below. Merge those cells, left align it right here, and then in italics, so Control-I for italics, capital N, and then OTE for note, unitalicize, bold, coefficients are significant. And then we'll put Control-I for italics, P, less than 0.05. Because that critical value I gave you is a two-tailed test with an alpha level of 0.05. Now, look at this. You see the grid lines. That's because I have view grid lines selected. You may not see that on your end, but if you're under layout, you've got view grid lines here. Let's go ahead and make sure that's unselected so we can see what this is actually going to look like. Now the lines are almost good, but we need to mess with them a little bit to make it APA style. So let's go ahead, go to the bottom left, the last row here where we put our note, and wait until you get a little right pointing white arrow and click it. That highlights that whole row. go under the Design tab under Table Tools, and make sure that we have a bottom border and that we get rid of, or sorry, that we have a top border, but we get rid of the bottom border. And then here, do the same thing to the top row, white arrow, and let's get rid of that top border. Let's see. There. I clicked it twice to make it go away. And technically there's supposed to be a space right here as well. All right, now we have a gorgeous APA style correlation table. There we go. Beautiful. And if you want to, just because it might be bothering you like it is me, you can put little dashes here if you want. And let's go ahead and center our values as well. So we want to highlight all the numbers like that. Go up to layout and center those. There. Now we're cooking. Gorgeous. And your table should also have all of the significant correlations in bold. So for instance, this one is definitely significant. It exceeds that critical value of 0.11. So I could hit Control B to bold it, or I could just click bold up here under the Home tab to bold it. So make sure you do that on your own. Now I want you to look at these and pick out which relationships are not statistically significant. So I'll give you one answer. And then whenever that happens, if it tries to automatically do a 3, just hit stop automatically creating numbered lists and it'll stop it for you. All right, so the first one I see that's not statistically significant is right here. And all you have to do to read this correlation table is to figure out where the two variables are connected, right? So if we look at this number, this is variable 1, which is household income, and then age. This one is the relationship for 1, household income, and political preference, and so on and so forth. So I know this one is not significant. It doesn't reach that criteria for significance down here. So I would put age and household income on number 2 for one of my answers. Age and, if you want to be lazy, you can just highlight household income, Control C to copy, put it down here, Control V to paste. And there's one of your answers for that. If you want to make my life easier, you can even highlight this under Home and you can bullet those answers and then just hit Enter and give me your next answer there. All right. Now, next, I want you to pick a significant relationship that interests you. So go back up to the table, find one of the bold values that's interesting to you. What two variables are kind of interesting? So for me, if I did, and you can't do this one because I am, if I looked at household income and social circle mean income, right, this one right here, I would put household income, social circle mean income for A and B, and then the correlation coefficient would be 0.49. And if I wanted to explain that relationship in plain English, since it's positive and it's also strong and significant, I could say those who have a higher household income tend to have friends with a higher household income, or at least they think they have friends with a higher household income. Conversely, because remember, positive relationship, X and Y change in the same direction, so you can have higher X tends to relate to higher Y, or lower X tends to relate to lower Y. You could say those with a lower household income tend to perceive that their social circle makes less money. Be really careful when you're explaining these relationships in plain English. Always avoid statistical terminology. Be specific, higher, higher, lower, lower, higher, lower, however it goes in terms of direction, and don't overstate the causality of that relationship. You wouldn't say those with a higher household income have friends with a higher mean income. They tend to have friends with a higher mean income. All right, number 4. So what is the correlation coefficient between estimated population mean income and household income? So you'd need to go up here. Household income is number 1, so you could just look here and then find population mean income, and there's that correlation. Then I want you to explain that relationship in plain English. So before we move on to the regression analysis, I want to take a look at this table and see how it matches up with the journal article for this study where the data came from. So let's go ahead. I'm going to just do kind of a split screen situation here to see how well that works. Let's make this a little bigger. All right. Now you're welcome to look at, let's see, what page is it? It'd be 1,393 up here, but page 5 of 12 on your data, or on your article, and kind of follow along with me here. Let's see if we got something similar to what they got. Now remember, they had a slightly different sample in theirs because I had to delete everybody who had missing data and they did not. So let's take a look at this. Social circle mean income and household income. 0.48, oh, 0.49, right? Look down here. Population mean income and household income. 0.19, pretty close with 0.18. We've got these two I didn't include because they were a little bit complicated. So let's skip to fairness and satisfaction with household income. Oh, that's exactly the same. Support for redistribution in household income, negative 0.21. And then political preferences in household income, 0.15. I also included age in this analysis just because I thought it was interesting. And notice that your table looks like this table here. The only difference is that they distinguish between these different levels of significance, and they used asterisks instead of bold. They also included their mean and standard deviation here as well, which I didn't have you do. But if you look here, whenever you're trying to interpret a correlation table in a journal article, this is what it's going to look like. And you see you've got the numbers here, and then they're reflected here. They don't have anything here. They didn't even give you Cronbachs Alpha for multi-item scale scores. Shame on them. But anyways, you see this, right? P less than 0.05 means that it's significant with an alpha of 0.05. 2 asterisks means it's significant with an alpha level of 0.01. And 3 means it's significant with an alpha level of 0.001. So the more asterisks you have, the less of a probability there is that that relationship is just due to chance. But for our purposes, we just stuck with 1 alpha level, 0.05, and we bolded them, which is totally fine as well. Just wanted to show you how what you created is exactly what researchers are doing in the real world with their data. All right, now we're ready to move on to regression. So let's go ahead and go to Excel, and we are going to predict estimated population mean income based on household income. So in this case, our independent variable, our X variable, is going to be their household income, and that's going to predict Y hat, the estimated population mean income. So the theory is that if you make more, you're going to assume that other people in the country make more as well. You're going to be less attuned to the struggles of those with less money. That's kind of the theory of the paper. So let's go to data analysis. Make sure the data tab is selected up here, data analysis, and then go down to regression and click OK. And I already did this before, so it's already programmed, but let me get rid of this. All right, so make sure that your input Y range is the thing you're trying to make predictions about, your Y hat, so to speak, your dependent variable. And in this case, we think that the estimated population mean income depends on your household income. So our Y range, our Y variable, is population mean income. So just make sure your cursor selects that box, click and scroll down, including the label and the values below it. So notice the label is included here as well. And then make sure that little box next to labels is checked. Now I want you to click in the box next to input X range. That's our independent variable. That's our predictor. And we think that household income is the predictor of population mean income estimations. So with that box clicked, I'm going to just click household income. I'm just going to do it this way. Scroll down, hold shift, and click the last value in my data set. And it highlights everything in between. Labels is selected. Make sure you get a new worksheet and type in regression, and that'll pop it up down here. We're ready. I'll give you a second to type. All right, let's hit OK. Bam. Again, I'm going to scoot this down because it's bothering me. Now, these are kind of messed up values right now. There's some E messages and some weird stuff. So what we need to do is right-click, make sure all the things are highlighted, go to Format Cells, Number, and let's go ahead and round to 3 decimal places and click OK. You also want to make sure that you're able to see everything here. Some of this stuff is cut off. So go up to the Home tab, go to Format, AutoFit Column Width, and we're golden. Let me show you a couple things in here before we figure out what the regression equation is and then make some predictions with that. So this is your multiple R. Since you only had one correlation coefficient, this is the same as your raw correlation. And if we go and we look at that correlation between household income and population mean income, it's 0.18. Here it's 0.185, but it's pretty much the same. R squared is your effect size. So what this tells you is that 3.4% of all the differences in people's estimated population mean income, 3.4% of all the differences in those estimates of the population mean income are attributed to their household income. The adjusted R-squared accounts for sampling error. We won't talk about that. Here's your standard error. Here's how many people were in your data set. This is the analysis of regression that you learned about to see if there is actually a significant relationship, or in fact, if household income is a significant predictor of assumed population mean income. And you see here that it is, right? This is less than 0.05. This F value is rather large as well. This is the most important piece. Really, this is the most important piece of the regression output. And this is what tells you how to interpret the regression equation and what values to plug in. So your intercept is the same as A, the last part of your regression equation. And then this is your B. This is your coefficient for household income. So if we just, let's see, I'm going to just copy this piece. Control C to copy, put it into my Control V paste. There's our coefficients. And what we could do is we could write out our regression equation as, instead of writing y hat, you'd want to write predicted mean household income in the population. That's our y hat. Equals, remember, the coefficient for household income is 0.067 times whatever their household income is, plus our constant, our intercept, which in this case is 55,333.121. That's our regression equation. So with this equation, we can plug in anybody's household income and make a prediction of how much they think everybody in the population makes on average. I'm going to go ahead and copy this, Control C, and paste it into my worksheet to show you how to use Excel to generate those predictions. So in the assignment, I asked you, using this equation, predict the estimated population mean income for all these different values. So $40,000 a year, $140,000 a year, and $240,000 a year. So if we say household income equals, and we put, let's see, 40,000? Yep. 40, 1, 2, 3. Don't put a comma in there, just put in 40,000. 140, 1, 2, 3, thousand, and 240, 1, 2, 3 for 1,000. Predicted mean pop income. Just kind of abbreviate it there. I'm going to do a little double click action. So, whoa, that's too much of a double click. Let's shrink it down to this. Equals. So we're going to use the formulas in Excel to generate these predictions without having to actually bust out a calculator. And the nice thing is, once you do it once, you can copy the formula across for all those different values. So check this out. Equals. Remember the equation up here, right? So we're going to put, and we want to put this whole thing in parentheses. So a left bracket. So equals left bracket. Click on the coefficient for household income. Hit F4 to lock it in so that it is fixed no matter which cells we move to with our formula. Then put a little star for multiplication. And then we're going to multiply it by the household income right here, 40,000. Close it with a right bracket. So that's this piece right here. The coefficient for household income times the actual household income we want to make predictions with. And then we're going to do plus the intercept, or the constant, which is right here. Let's just click that. Hit F4 to lock it in, and then hit enter. Now you can click this, go down to the bottom right corner with the little plus sign, drag it over. What the heck? Let's see. There we go. Just double click it so it's big enough. It just turned into weird numbers because it was such a big number. And I am also going to right click these, make sure they're all highlighted. Right click, format cells, and let's make these currency and round to 2 decimal places. That looks a lot nicer. Now check this out. remember, the regression equation is linear. So for every $1 increase in household income, we expect their predicted mean household income to go up by 0.067. So if you think about this, this is constantly increasing by $100,000. And if you take 100,000 times, and let's put an equals here, equals 100,000 times 0.067, you should see that for each $100,000 increase in household income, you're expecting their predicted mean household income in the population to go up by $6,700. So let's see if that's the case, right? Because this is a $100,000 difference. This is a $100,000 difference. 100,000 times 0.067 is 6,700. So if we do this, equals this minus this, we get that, okay, equals this minus this. And we get basically within rounding error that $6,700. It's neat. I'm going to get rid of this. I just did that to show you how that works. Okay, so now you have the values that you need to plug in to your assignment right here to see those predictions play out. Now I'm going to show you how to create a scatter plot of the raw data and make a regression line. So we're going to go into Excel, go back to your data, and now we want to make sure that the two variables are adjacent. So we're looking at population mean income and social circle mean income. So just right click here and click Insert. Then click that little E to highlight all this. Hit Control X or right click Cut. Go here, Control V, or right click Paste. And I'm just going to delete this. So now these two things are next to each other. So go ahead and highlight the B and C column, your two variables that you want to make a scatter diagram for. Go up to Insert. You're going to choose the scatter. Go ahead and choose the one that looks like this first. And now you can kind of see what's going on here, right? Now this is not very beautiful, so let's make a couple edits to this. Let's go to Quick Layout, and let's see if this looks a little better. Let's see. Nope. We're going to do it manually. So go to Add Chart Element, Axis Titles, Primary Horizontal. Add Chart Element, Axis Titles, Primary Vertical. Here, we're going to change this to Estimated Population Mean Income. And down here, for this axis title, just click it and highlight it. Household Income. Let's also get rid of this population mean income thing right here. And so now, let's make it a little bit bigger too so we can see all those values along the bottom. That's better. Now if we look at this, and we need our regression line, so under Design, Chart Tools, Add Chart Element, check this out. Trend line, linear, there's our regression line. Let's go ahead and copy this and paste it into here and take a look at it. So this is neat. So here's our X, here's our Y. If we go in just real quick to confirm this regression line, let's see if it works out. So if we go to our regression output, for somebody that made 240 grand last year, we predicted that they would estimate the population mean income to be about 71. So if we go here, here's about 240, and look, that's about 71, right? That's where that line is. We can also see that this is a moderate positive relationship. It's pretty spread out, but we can tell that it's going upward. And you also notice that regression line is always in the middle of your dots. All right, so I hope that this helped you understand correlation and regression a little bit better and also taught you some really useful tools in Excel for how to generate that without doing all those fun hand calculations.